So today we're actually going to be talking about how to read a circuit diagram. Okay, so I have here an actual circuit with a battery. In case you're wondering what kind of battery this is, it's a 6-volt battery that goes in some lanterns. I got it just because it was easier to attach the alligator clips. Okay, so we have a battery, we have two wires, and then we have this resistor right here. Okay, now over here on this side, we have our diagram. Okay, so the battery, that's represented by this. So this is the symbol for a battery. So down here, right here, symbol for a battery is that. In case you're wondering what this is a cell. A lot of times batteries are made up of several cells to increase the voltage. Okay, so the wires are pretty self-explanatory. They're a line. So the wire going up and over, and the line coming down and over. Now, this right here is that resistor. Okay, so we can see the resistors right here. Okay, and we haven't gotten to it yet, but the light bulb, when we actually have light bulbs or LEDs, they'll look like this. A little circle with an X through it. And lastly, a switch. So this shows that it can be both open and closed. So that's the symbols. Now let's get into how to actually read the diagram and figure out how much current is flowing, what's the resistance, all that. Okay, so first up, let's test the resistance. So we actually don't even need to take the alligator clips off for this. So I'm just going to click this to the positive, this to the negative, and we get about 6.4. Okay, so this is 6.4 volts. Okay, next let's test the resistance. And for this I am going to disconnect this. So I'm going to set the resistance on the multimeter, and then that would be, even though there's not a decimal point, that would be about 100 and, let's say 105. Okay, so we got 105. Remember, that's ohms. Okay. Now, how much would the current be? So the voltage, we're going to start with V equals I times R. Voltage is 6.4. The current we don't know. And the resistance is 105. So what we do, if you take 6.4 divided by 105, and our current, okay, our current is 0.06. Okay, so that's how many amps would be flowing. So that's about 60 milliamps. So 0.06, same as 60 milliamps. Okay, so let's actually test to see how much current is flowing through it. So I'm going to connect these two together. Then I'm going to connect the black to one side of the resistor. And before I do anything else, I have to change the setting. So I'm going to change this to 200 milliamps because it should be in that range. And that's how many milliamps we have. So our calculation of 60 milliamps, this reads as 64 milliamps. Okay, so pretty close. Again, there's going to be some losses in the wire and all that. So let's do another example. Okay, so this time, so this was rated as a 100 ohm resistor. So again, there's plus or minus 5%, or actually usually 10%. So now we have, okay, so now we're going to try this, which is rated at 24 ohms. And again, let's test it and see. So we're reading about 21 ohms. Okay. So in this case, I have my resistance is 21 ohms. And my voltage should be the same. So let's test it out. And we have 6.5. Okay, maybe a little bit better connection than last time. So voltage 6.5 volts. Okay, so we want to figure out the current. So again, we're going to use Ohm's law, V equals I times R. Voltage 6.5. Current, we don't know. And resistance this time is 21. So we divide both sides by 21 and is equal to 0.31. And that's amps. If we wanted milliamps, we would move the decimal place 3 places and we'd have 310 milliamps. So let's actually test it out. So here I'm going to hook this up to the positive. Going to hook this from the multimeter to this side of the resistor and then back to the battery. And oh, I forgot to switch it over to current. So and we're actually reading out of off the chart because that's 310 milliamps. This setting can only go up to 200. So I'm going to remove this, put it up here, and change the dial. So this says it's reading about 0.25 amps, so a little bit less than we calculated. And again, there's going to be some losses in the lines, okay, and all these connectors. There's going to be some slight resistance. So that's the actual circuit and what it will look like in a diagram. Okay,